In this lesson, the objective is to find the vertical and horizontal asymptotes of the graph, and we're going to do this by looking at some examples. Let's talk about a continuous function. If a function is not continuous at a point in its domain, then we can say it has discontinuity there. And here we have an example. See this graph, there is a hole on it. So that's one point of discontinuity along the domain. And there is an asymptote, so that's another point of discontinuity. There are two types of discontinuities we see here. These discontinuities have names. If we have a hole, see this here is a hole, we call that a movable discontinuity. And see this one is like a piecewise function. You can see the point of discontinuity. It's called jump discontinuity. And here you can see we have infinite discontinuity where we have an asymptote. So three types of discontinuities. So here let's define a vertical asymptote. If x minus k is a factor of the denominator but not a factor of the numerator, then x minus k is a vertical asymptote of the function. Let's do an example. Find the domain of this function. So the first thing is to factor the denominator. We factor the denominator, and then after factoring the denominator, we can see x minus 3 is common. So if x minus 3 is common, we can cancel it out. So what we realize here is that we have a vertical asymptote at x is equal to minus 4, and the domain is all real numbers except negative 4. But let's move on to investigate. If you graph this function, you can see that if you plug in 3 into the function, you get a situation where you are dividing by 0, which is undefined. So here I need to say that the domain is all real numbers except negative 4, which we already got on the previous page, and 3. But where did this 3 come from? This 3 comes from what we cancelled out. So whenever we cancel out the factor, we make a hole in the graph. So here, let's define a hole. If x minus k is a factor of both the numerator and denominator, and note here we are saying of both numerator and denominator, then there is a hole in the graph. A hole is created when you cancel out the common factor. So here, if I want to know the specific location of the hole so that I can include it in the graph, I can put 3 or substitute 3 into the simplified function, this one. And when I do that, this is how I work it out, and I get 1 over 7. So the coordinates of this hole are 3 and 1 over 7. So here we look at another example. Find the domain and classify the vertical asymptotes and holes. So I have the function, factor it. So I see here x plus 1 is common, so I know there is a hole. So there is a hole at x is equal to negative 1, and there is a vertical asymptote at x is equal to 3. So the domain is all real numbers except 1 or negative 1 or 3. To know the specific location of the hole, I take negative 1, which is the location of the hole. I plug it into the simplified function, and I get negative 1 over 4. And here we go, that's where the hole is located. And so when I graph it, this is how it's going to look like. Okay, now let's talk about the horizontal asymptotes, and there are 3 rules to consider here. So the first one is the degree of numerator equal to the degree of denominator? If that is true, you take the coefficient of numerator minus coefficient of denominator. If the degree of numerator is less than, then you get y is equals to 0. If degree is greater than, then no horizontal asymptote. So you need to write this down and you keep coming back to them. Example. So find all asymptotes. So I'm going to start with factoring. So I factor it out. And one thing I realize is nothing cancels out. So what that means there are no holes. So their vertical asymptotes are x is equals to -1 and x is equals to 3/2. And these are the zeros of the denominator. I get them by equating each denominator to 0. So I have my vertical asymptotes. So what about the horizontal? I just need to check the degree of numerator. It's less than the degree of denominator. So that means the horizontal asymptote is y is equals to 0. And when I graph it, I can be able to see the same thing. Okay, the next one here. So here, again, we start by factoring out. So there is a hole at 1 because you can see there is a common factor. I plug in 1 into the simplified function and I get the specific location of the hole so that I can graph it. And then I write the vertical asymptote at -2. And then I compare the degrees. Since the degrees are equal, the horizontal asymptote is given by the leading coefficient of numerator divided by leading coefficient of denominator. In this case, it's going to be y is equals to -1, and then I can graph it. Okay, here I have another one. Find all vertical asymptotes. Again, I factor it out. So I see there is a hole at x is equals to 5. I plug in 5 into the simplified form. I get 2 and 4/7. So the specific location of the hole is right there. So I graph it. Then I know there is a vertical asymptote at x is equals to -2. I compare the degrees of numerator and denominator, and they are equal. So when they are equal, I just look at the coefficients and I see they are 3/1. So y is equals to 3, and there is a graph. And the last example here, I'm given the function, so I factor it out. And you can see one of the factors is common. Since this is common, there is a hole at 3. You plug in 3 into the simplified function and you get 4.5. So there is a hole at 3 and 4.5. And this is the hole when we, so that's the hole right there. And then what do I do next? I write the vertical asymptote and I show it on the graph. So then, and this is the vertical asymptote right there. Then I need to look for the horizontal. The degree of numerator is more than degree of denominator, so it means there is no vertical asymptote. Sorry, no horizontal asymptote, but a slant asymptote. And you can see how it looks right.